Hello. In the next few videos, we're going to be doing Maclaurins and we'll go through some of the few key concepts of Maclaurins. So what Maclaurins actually is you are trying to convert any function or any combination of functions, for example, this question. What Maclaurins does is they will convert this and approximate it to a polynomial. This is extremely important when we can convert ugly looking functions like this, or even functions with a mixture of exponential and trigo inverse. All of these can be converted into polynomials. Why you need to convert into polynomial is because polynomials are easy to handle, they are easy to solve, they are easily differentiable, and they are easily integrable. Meaning, for example, if these can be converted to 1/2 plus 3/4 x minus 3/7 x squared and so on, differentiating these will be just a breeze, right? Because differentiate, you can just apply differentiation to here, 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 and so on. Integrating this will be easy as well. Solving this is also easy because you can just use poly SMLT, and this is just polynomial of degree 2 or maybe degree 3, depending on how many terms you want to add. The thing about Maclaurins is the more terms you add, the better the approximation. If you were to just use 2 terms, for certain values of x, they can be approximated pretty well. But if you add more, the approximation will be even better. So questions will tell you where to go up to. In this particular one, they are only asking you to go until x squared. So to do that, we will need to come up with a series of items, a staircase of items, or I like to call them, which is f0, f prime 0, f prime prime 0, and so on, all the way until f prime 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 0, depending on what they want. So if they want x above 2, we will stop here, 2 primes. Let's start off with this question. So let me just copy down. The first part asks us to just show that the first derivative will get me this. Okay, so let's go ahead and do this. Nothing too fancy. Let's just differentiate it as per usual. We will be using product rule. 2 items. We will hold this one. So that will give us here. And we will differentiate this one. This is differentiating cosine inverse of fx. Differentiating cosine inverse of fx gives us f prime x negative over square root 1 minus fx squared. So here, this will give us, differentiating this will give us 2 negative over square root 1 minus 4x squared. Then we'll do the other way around. Since we held this, we differentiated this. Now we will hold the cosine inverse and we'll differentiate this. Differentiating this gives us half, power bring down, right? Copy, and then power minus 1, and then we multiply by the differentiation of the inside, which is just negative 8x. Then let's clean this up. This cancels off with this. This will just give us negative 2. Very nice. And the next part, we will get cosine inverse 2x. Half and negative 8x will give us negative 4x over square root of 1 minus 4x squared, because this is negative power negative half, so it's a square root that lives in the denominator. So to clean this up, let's take a look at what the question wants us to do. They want us to incorporate the y back. Can you see here? They want us to incorporate the y back. How do we incorporate this? Take a look at just this part. Cosine inverse 2x is simply y over square root 1 minus 4x squared from the very beginning. So this becomes negative 2 plus y over root 1 minus 4x squared times negative 4x over square root 1 minus 4x squared. All we need to do now is simplify this. This will give us negative 2 plus negative 4xy over 1 minus 4x whole thing squared. Now all we need to do is multiply both sides by 1 minus 4x squared to give us And then we will bring this over to the left-hand side. Which is exactly what they want us to show. Oh, they want a positive 2. So you notice that we have a negative 2. All we need to do is incorporate the negative into the bracket. And then we switch places. So we will get this. 4x squared minus 1. Shown. And then to continue, let's build up on this by further differentiating the result. Find the Maclaurin series of y up to and including x squared. So then, this is now findable. We can also make use of our previous result to find f prime 0. And then we are just lacking f prime prime 0, which requires us to differentiate this another level down. So let's just go ahead and differentiate this. To do this, just do this whole thing implicitly. Hold 1 minus 4x squared, differentiate dy dx, plus, now the other way around, because there's 2 items, the other way around will be hold dy dx, differentiate 1 minus 4x squared, plus, second item, we will use product rule as well. Hold 4x, differentiate y, plus, hold y, differentiate 4x, equals to this side, we will just get 2 times 8x. So now we can just clean this up, or we can just stop here and make use of the staircase of result to help us find what is f prime prime 0. Very easy. To find f0, just go back to our original equation here and set x to be 0. Y would be square root of 1 minus 0, which is just 1. Cosine inverse 0 would give us pi over 2. So f0 would just be pi over 2. So first part is done. Next one, find f prime 0. Now you can use pi over 2 every time you see a y. So here you will get pi over 2. And every time you see an x, just put in 0. So first of all, the easiest thing to do is find the item that will just be gone. So this will be gone, right? Because x is 0. So here, x is 0, so this just becomes 1, which is just dy dx, plus 0 equals to 2 times 0 minus 1, which is negative 2. So f prime 0 is negative 2. So this means that x equals to 0, y equals to pi over 2, and dy dx equals to negative 2. Throw all these results in here. This would be just 1. This would just be d2y dx squared. This would just be negative 2 times 0, which is just 0. Here, 0. Here, 4y is 2 pi. And here, 0. So you get d2y dx squared plus 2 pi equals to 0. d2y dx squared would be negative 2 pi. Now to gather all of these, just go to your MF26 here and check out this particular Maclaurin's expansion formula. Snip it off. And then I'm just going to put everything into place with what we have found. So y would be f0, which is pi over 2, plus x times f prime 0, which gives us negative 2x, plus x squared over 2 f prime prime 0, which will give us negative pi x squared, plus, and so on. Of course, if you were to increase the accuracy, we will just increase the number of terms, which means that we will have to differentiate this one more level down to find f prime 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 0's coefficient of the x cubed. The second and last question of this video is just question number 2, NGC Promo 2012. Given that y is this, now show that y times d2y dx squared blah 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 gives you this. So you want to show until the second differentiation. So let's just go ahead and do this. Notice this actually would be way easier if you square both sides. Squaring both sides will be a much easier time because you can then use implicit differentiation. I'll show you what I mean. Y squared is equals to 1 plus tangent inverse x. Leaving the square root here would be quite a nightmare because you will have the power bring down, power minus 1, differentiate the inside, which gives you another fraction. So that's pretty challenging to do. However, if you were to do this and just do the implicit differentiation, then the question would become slightly easier. Implicitly differentiate this will give us 2y dy dx equals to 1 will give us nothing. Tangent inverse x will give us 1 over 1 plus x squared. And so we're done with the first level. Do this another level down. Differentiating this, we'll need to do product rule. So hold 2y, differentiate dy dx, plus hold dy dx, differentiate 2y. So dy dx, differentiate 2y will give us 2 dy dx. And on the right hand side, because this can be written as 1 plus x squared power negative 1, this will just give us negative 1 over 1 plus x squared squared. And then differentiate inside gives us 2x. So we're going to put the 2x above. So you start to see some kind of similarity to this. Notice now there are 3 items. 1, 2, and 3. All of these is a 2. So we're going to eliminate both sides by 2. Divide both sides by 2. We're just left with this. And then simplifying will give us y dy dx squared plus dy dx whole thing square is equal to negative x over 1 plus x squared square, which is what the question wants. So we're done with the first part. By further differentiation, obtain the Maclaurin series up to and including x cubed. So now we need to do one more level. To continue on from here, differentiating this would require us to do product rule once again. So hold y, differentiate this, plus hold this, differentiate y, plus differentiate this will be using chain rule, right? Power bring down, copy, power minus 1, multiply by the differentiation of the inside, like that. So for the right side, let's just do it brute force. Below would be 1 plus x squared square, and you square it one more time, it will give you power 4. And we will be using quotient rule, right? Hold bottom, differentiate top, minus hold top, differentiate bottom. Differentiating bottom gives us 2, 1 plus x squared, 2x. Let's simplify the top, negative 1 plus x squared, plus 4x squared, 1 plus x squared, over 1 plus x squared power 4. Factorize out 1 plus x squared above, it will give us 4x squared minus a copy of 1 plus x squared, divided by 1 plus x squared to the power of 4, because this can be cancelled with this, so this gives us power 3, and if we were to clean up this, it will give us 4x squared minus x squared, which is just 3x squared minus 1. Now let's do the entire staircase of results. F prime prime 0, F prime 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 0. Starting off with the very first one, using x equals to 0. Go back to the question. Y would be 1 plus tangent inverse 0, which is square root 1 plus 0. 1. Using this value, go back to this stage here, and if your x is 0, your y is 1, your dy dx would be 2 times dy dx equals to 1. dy dx will just be half. Next stage, come back to here, this one. So this will give us the 2y dx squared plus 1 quarter equals to 0. The 2y dx squared is just negative 1 quarter. Coming to the third stage, every time we see a y, we put in 1. So this is 1. The 3y dx cubed, and then this would be just half times negative 1 quarter, negative 1 over 8. This would just be 2 times half times negative 1 quarter, and on this side, you will just get 0 minus 1 over 1, which is just negative 1. Simplifying this, the 3y dx squared would be negative 5 over 8. Put this all in place using the Maclaurin equation. Y will be approximately equals to 1 plus half x minus 1 over 4 divided by 2, which is 1 over 8 x squared, plus negative 5 over 8, 3 factorial, right? This will give us negative 5 over 48 x cubed. Put the negative here, and we're done with the first part. Second part, we have to deduce this, which you actually can see that the top part is what we have already done. Y equals to root 1 plus tangent inverse x actually gives us this polynomial here. if they want this, this can be written as this multiply by 1 minus x to the power of negative half, because it's square root 1 minus x at the bottom. So if we were to force it up, it will look like this. This part is simply our previous answer here. 1 plus half x minus 1 over 8x squared minus 5 over 48x cubed. Multiply by this one. How do we find this? We just need to go back to our MF26 and make use of this binomial expansion here, which will give us 1 plus nx, negative half times negative x gives us half x, plus n times n minus 1 over 2 factorial of x squared. X in this case is negative x. Negative x squared gives us x squared. Now, do we stop? Yes, we stop, because they only want us to go until x squared. In fact, you don't even need this part here. So I'm going to go ahead and destroy this. Dot, 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 dot. Now, just clean this up. You will get 3 over 8 x squared. All you need to do now is expand this, and you'll get the answer. 1 times 1 will just give us 1. Now, collect all the x coefficients would be this times this and this times this. 1x, which is just x. And then now we collect all the x squared coefficients, which is this, this, and this. 3 things. 3 over 8x squared, 1 quarter x squared, and negative 1 over 8x squared. Simplifying this would just give us 1 plus x plus half x squared. That's it. Final part of final question, we will deal with small angle approximation. So a quick introduction of what small angle approximation is. Before doing that, let's take a look at the MF26 of trigonometry expansions. Now I'll focus on the sine x and cosine x expansion. I'm going to extract this out. If you were to expand sine x using Maclaurins, meaning you could do the whole sequence of ladder, f0, f prime 0, f prime prime 0, and so on until f a lot of prime 0, you will actually get this entire string of values here. The thing is, ask yourself, if x is small, does increasing the number of terms actually increase the accuracy? For example, if x is this small value of 0.01. Notice when you add on the next value, it will be x to the power of 7. Imagine if you have 0.01 to the power of 7, this actually gives you 0.000000001. 7 zeros followed by a 1. Does actually subtracting this over 7 factorial do you any good? Does it improve the accuracy? The answer is no. In fact, for small angles such as this, using just this would do. You don't even need the x cubed, because x cubed would actually be 0.0001. It doesn't improve the accuracy by subtracting such a small number away. Similarly, for cosine, we do not want powers that is 3 and above. So we are only collecting up to here. This would do for small x values. For x to be sufficiently small, x cubed and above, you can neglect it. So the 3 small angles that you need to remember is sine x is approximately equals to x if x is small. Cosine x approximates to 1 minus x squared over 2, and tangent x approximate to x as well. This last one is not in the formula sheet. You have to know it yourself. So let's just go ahead and do this question. Given that tangent x minus pi over 4 minus cosine 2x equals to negative 10, show that it leads to here. Tangent x minus pi over 4, we will be using the tangent addition formula, which gives us tangent x minus tangent pi over 4, which is 1, divided by 1 plus tangent A, tangent B. Tangent B gives you 1. Tangent A just gives you tangent x minus, now cosine 2x will approximate to, if this is a 2x, every time we see an x, we replace by 2x. This will give us 1 minus 2x squared over 2. And on the right hand side, it is still negative 10x, because you do not apply a trigo to the x here. So there is no Maclaurin's expansion for negative 10x. Negative 10x, you don't have to expand it using Maclaurin's, right? It is still negative 10x. Now, going on, tangent x, which is approximate to x, so this gives us x minus 1 over 1 plus x minus, oops, I left out the bracket here, minus 1 plus 4x squared over 2, which is just 2x squared, equals to 10x. I'm going to multiply throughout by 1 plus x, which gives us x minus 1. 1 minus 2x squared times 1 plus x equals to 10x, 1 plus x. Simplifying this, 1 plus x minus 2x squared minus 2x cubed equals to 10x plus 10x. Oops, negative. Negative 10x minus 10x squared. X minus 1, 1 minus x plus 2x squared plus 2x cubed plus 10x plus 10x squared equals to 0. 2x cubed plus 12x squared plus 10 minus x plus 10x minus 1 minus 1 minus 2 equals to 0. Divide throughout by 2, which will give us x cubed plus 6x squared plus 5x minus 5x minus 1, 0. And now the final part of the question, they say hence find an approximate value of x, leaving answer to 3 as f. All you need to do is solve this equation. Solve this equation, which we just came up with. Go to our calculator and we will key in 1, 6, 5, negative 1, and the answer negative 4.95, 0.166, negative 1.22. Remember, x is small, so this is clearly not small, this is clearly not small, which leaves us the answer with just these 0.166. That's it. Thank you.